Hello, everybody. Thanks for having me back again. Glad you guys aren't tired of hearing me talk. So, as we said, we're going to take a little break from biology and do a little bit of astronomy now. All right, so what is LCOGT? I'm sure a lot of you here can probably answer this already, but what we are, for the new people, is that we're a nonprofit organization located right here in Santa Barbara, and we're creating this new tool that nobody's ever really succeeded in before for cutting-edge education. Let's see here. We're building this big network of about 42 to 44 telescopes ranging in sizes from about 0.4 meters to 2 meters, and we'll have 24/7 all-sky coverage. And as I said, we'll have a big science program and also a big education component to go along with that. So this is going to be our telescope network. These are our confirmed sites. So we've got already in place our 2 2-meter telescopes in Hawaii and Australia. And then joining them very, very soon this year will be Chile and South Africa. We have our 1-meter telescopes almost ready to be shipped out, and the sites are just about ready to receive them. And with the 1-meter telescopes, we'll be shipping along at least a 0.4-meter telescope. And so hopefully very, very soon, you guys will be able to use these telescopes. As you can see, we have actually a big gap up over there in the Asia region, and we have a couple of potential sites that we are looking at to close that gap. So we really have true 24/7 coverage. Okay, so these are our 3 classes of telescopes. Up here at the top, this is Fox Telescope North in Hawaii. We have 2 of these. Its sister is Fox Telescope South in Australia. These have been in operation since about 2005. They were originally built for UK school kids, and then we acquired them towards the end of 2005. And we still do a lot of education on them with the UK schools, and a little bit alliance as well. And we have a little bit of time we've given to some local students here, and I can talk about that more later. We also are building about 12 to 15 1-meter telescopes, and this is our prototype 1-meter telescope. It is currently sitting in a dome in our back parking lot in Santa Barbara. It's great for testing reasons, not great for science because of the light pollution and the marine layer here, but we are actually getting some good results from that. We're going to have about 2 to 3 of these at each site that we're going to. And then up over here, we have our 0.4-meter telescopes, which we're going to have 24 of these, and they're basically 16-inch Meade RCX telescopes, completely stripped down, mounts thrown away. We have a custom-designed C-ring mount, which is the same as our 1-meter mount. And we've completely redone all the innards of it, kept the optics, but everything in there is brand new, custom designed. It is in an enclosure called an agawan, which is a custom-designed enclosure. Not the best picture of it there, but it's the Chumash word for keep dry, which is very important for telescopes and electronics. And we'll have 2, 3, or 4 of these at each site as well. All of these telescopes are going to have really high-quality instrumentation, research-grade CCDs. We'll have at least a spectrograph at each site, a high-speed camera. High-speed cameras on our 0.4-meter telescopes will be really good for planets or the moon, really, really bright objects that are too bright for typical CCD cameras. Okay, so our education program has actually taken a turn from what I told you last year. So you guys have a little bit of new information here. And we're actually going to do a citizen science approach, and I'll talk more about that in a second. We're going to have our research projects, everything going to be online, resources, forums, activities, you name it, everything's going to be online. Key research projects, we'll have probably a handful of our top ones, and then everybody's always welcome to create their own, do their own thing. This is going to be open to anybody and everybody. Your students will be able to use it, you'll be able to use it. If you were doing Girl Scouts or Boy Scouts, if you're going to a nursing, anybody and everybody can be using this. So unfortunately, we don't have any time available for you guys yet, but hopefully very soon. But we do have a lot of things on our website already. We have about 5 years worth of data, maybe closer to 6 now, in our archive. It's publicly accessible to everybody. There's a link to it off of our webpage. You just got to go to observations on the side. You can download anything you want. We've got activities, what to do with the data. We have some activities that don't even require a computer. Everything is publicly accessible. And lots of information about us, and it's growing all the time. All right, so let's get back to the citizen science. Who here is familiar with the term citizen science? Okay, very few people. Does anybody want to take a guess at what it means? No? Okay. So citizen science is basically ongoing scientific research projects that anybody, basically volunteers, a lot of these volunteers don't necessarily have any training whatsoever in what they're doing, but they can start out very simply and just do really basic things. One really good example of this is a project called Galaxy Zoo, which I highly recommend you guys take a look at. It's a lot of fun. And what they started out is, okay, we're going to show you a picture of a galaxy. Is it spinning clockwise or counterclockwise? And it can be as simple as that. And that's grown into such a huge project. And we're kind of basing our citizen science program off of theirs because we saw how successful it is. And we're trying to open it up to more people. Okay, so we're really excited about this. We have our very first citizen science project starting out. We're going to release it in May, this coming May. And we're calling it Agent Exoplanet. And what we are doing is we are getting data of transiting planets, and then it's brand new data, and the very first eyes that are going to be seeing this data is an international group of volunteers doing this. So we already have a core group of users. It's based in Europe, covering several countries, but this will also be open to anybody here who is interested. The data will be taken automatically through the science queue, but then, which eventually you guys will actually be able to take your own data. But you guys will be able to do all the analysis and everything. And one of the cool things about it, you won't really have to download any data if we actually get our software working in time. So fingers crossed. Okay. And then these are just some sample research projects that have been done in the past using our telescopes, and some of these may also turn into be some of our key projects. We have a light curve of an extrasolar planet up at the top done by a student in Hawaii. We've got, actually this was a pair of local 8th graders from Goleta Valley Junior High doing an open cluster research, and they won 4th place in the California State Science Fair last year. So we're very excited about that. Up here we have a combined light curve of student data and professional data of a microlensing event. And this was done by a group of students in the UK who then blogged about their experiences. So you can, I can't remember the web address, but it's really interesting to see their take on it. And then over here we have a light curve of the white dwarf in the center of this planetary nebula done by another student in Hawaii. And we've got lots and lots more, but these are just a few sample projects. Okay. Now a little bit about our science, because a lot of our education programs are going to come from what our scientists are doing. And our two biggest things are extrasolar planets and supernova, but we also do some gamma ray bursts, Kuiper belt objects, near-Earth objects, open clusters, variable stars, a lot of different things. And we do a time domain astronomy, so things that vary over a course of time. So because we have this ability to do 24/7 observing, and our telescopes are designed to be quick response for things, gamma ray bursts that go off all of a sudden, and you never know when or where they're going to go off. So between those two, we can do long period observing, so we can get a 2-month straight observing session of an extrasolar planet without any breaks in it, and ideally if we don't have to deal with weather and everything like that. And then we do a lot of our both science and education, a lot of collaborations. So we share all the resources and just get a huge database of information and resources, data. So for more information, we've got our website, which is constantly growing. We do have a monthly newsletter now. We are also on Facebook and Twitter. There are links to those off of our website. Please feel free to email me if you have any more questions. And there's a little sign up for those coming to the tour tomorrow. Yeah, that's basically it in a nutshell. So there you go. Yeah, questions, comments?
Maybe I missed this. Did you mention, is there a spectroscopic capability?
Yes.
Oh, okay,
there
great.
will be, not yet, but we are in the process of building a medium resolution spectrograph. So we'll have that on the 1 meter telescopes.
I got a real quick question just for grins. What's the cost of a 0.4 meter telescope before you strip it down?
Oh, shoot. What was it? I think if you buy it straight from Meade, which they actually don't make this model anymore, I don't remember what it costs, but it's...
Somebody behind me is whispering an answer.
I think we paid a bit more than that. So I want to say about $15,000 or something. So it's up there. Yeah. Planets are, all we have are 2 meter telescopes right now, and planets are way too bright for those telescopes. I can show you several of the examples of people who have tried to take pictures of Jupiter or Saturn with the telescope, and you cringe when you see them, and they burn out the CCD for probably the next couple of hours. You get a ghost image on every single following image. So yeah, you can do that with our 0.4 meter telescopes, though. Just please not the 2 meters.
No more questions? Oh, there is a question.
Mine is just sort of a logistics question, and that is, in the future, do you plan on charging for the use of these telescopes, or how are they going to be self-sustaining? I know this is privately funded, but I'm still kind of stunned as to how you can maintain this type of network. Where is the funding coming from?
Well, for our education component of it, we are still planning to have it free. This may change in the future, depending on the economy, but for the moment, we are still planning it to be free and open access to everybody, and I personally really hope it stays that way. So.
I'm just wondering, out of curiosity, if you have any thoughts about, trying something like interferometry for too close telescopes anywhere.
We've thought about that. So, and there have been. I can't now remember what the project is, but somebody did use Fox Telescope North and South. Oh, wait, no, that's something else. Sorry. We can actually probably do that with the 1 meter telescopes now. Okay. Yeah, it has been thought of, but.
Yeah.
Okay, well, we're getting to the end. There's one more important person to thank who works on this all year round. Actually, 2 people at least. One of them is Dan. Where's Dan? Who is you've all been in touch with. But then, most important person who isn't here. If I wait long enough, maybe I shall come in. You already gone. What? They'll find her. So let's wait a moment. And But meanwhile, thank you all for coming and showing interest in this. And here's Jocelyn. Let's all thank Jocelyn. And of course, Craig and Monica. Craig has been running around with the microphones. And let's see, what was I going to say? Oh, yes. So enjoy the rest of Santa Barbara. The sun is still out. Tomorrow is going to be nice. And spread the word. There's plenty of room in this room, you notice in the back. So even if your friends and colleagues apply, you'll still have a place. Don't worry. Spread the word, and see you next year.